Hi there, grade 8 learners. In this experiment, our topic is density, and in this experiment we would like to find out what the relationship is between the mass of a substance and its volume. So here I have 3 pieces of wood. They have different sizes, so their volume would be different. I would like to move through the scientific procedure. So there should be an aim to this experiment, and the aim is to determine the relationship between the mass of a substance and its volume. The investigative question should start with what or how. So in my investigative question, it should be related to the aim. My investigative question would be, how does the mass of a substance change when the volume changes, and the density of the substance is kept the same. So when the density of substance is the same, what is the relationship between mass and volume? My hypothesis would be what I think the relationship is before doing the experiment. So I think that as the volume of the substance increase, its mass would increase. Then we need to do the experiment. Now we have already determined the dimensions of these blocks, and we used the equation V equals length times breadth times height to determine the volume in cubic centimeters. So what I'll do is I'll tabulate the results of our experiment. So we would have a column for the block. I've got 3 blocks here. Its volume in cubic centimeters. In your table of results, the measured quantities unit must appear as the heading of the column, and the mass, which was measured in grams. So our first block is this one. It has a volume of 8 cubic centimeters and a mass of 2,9 grams. Our second block, which is this one, has a volume of 11.3 cubic centimeters, and we could use 11, round this value up to 11, down to 11, sorry, and the mass was 4.12. The third block has a volume of 23.2 cubic centimeters and a mass of 8.36. Now, why I am making a video of this experiment and its results is to help you to get to draw a line graph that would show us the relationship between the volume and the mass. Now your graph should have a title And usually what we do is we draw a graph, and on the y-axis of the graph the dependent variable will be plotted, and on the x-axis the independent variable. So we first need to discuss this part: which of the quantities that we have here would be the dependent variable and which would be the independent variable. Now the independent variable in our case will be the volume. So the volume is the independent variable, while the mass depends on the volume. So we decided on what the volume of the 3 blocks would be, and we measured the mass. So we cut the blocks according to a specific volume, and we used the balance to get the mass. So volume is the independent variable, and that should go on the x-axis, and mass is our it depends on, and it is plotted on the y-axis. So our graph's title would be graph of mass against volume for wood, for a specific type of wood. Okay. Now, to calibrate the axis, the volume you must be able to plot from 0 to 23.2, so that's 24. Now, it's not possible to fit 24 centimeters along this axis or along the page. So what I'll do is I'll plot a graph that will, where two units would represent would be represented by a centimeter. So by the time I get to 12 centimeters, I'll be with 24. So 1 centimeter would be representing 2 cubic centimeters of volume. So 0, so it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and this would be the volume. In cubic centimeters. The mass axis must be able to go up to 9, from 0 to 9 units. So I can fit 9 centimeters on here on this piece of paper. So for mass, every centimeter would count for 1 gram. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 grams, and this is our mass axis with, in brackets, the unit we use to measure the mass. Now to plot the graph, I go to a volume of 8, and that's nice. This is the position of 8, and 2.9. Now because 1 centimeter would represent 1 unit, 1 gram, I can go up to 29 grams for 29 millimeters for 2.9. So from 8 on the volume axis, we can go 2,9 centimeters on the y-axis, and that would be our first point plotted. The second volume is 11.3. Now 11.3 is about 11. To plot the 0.3 on this graph, 11 is there. So 1 millimeter would represent 2 1 millimeter would represent 0.2 cubic centimeters. So 0.3 is halfway between the first and the second millimeter after 11. So it is there, and the mass is 4.12. Now 4.12 would be just above 1 millimeter from 4. So I would go 4.1 centimeters up. 1, 2, 3, 4.1. So I'm rounding this to 4.1. Okay, so our second point is there. The third point is at 23.2. So that's 1 millimeter to the right of 23, and 23 is there. So 23.2 would be at that point, 1 millimeter. So it's 6 millimeters from 22. And the volume is 8.36, which we can round to 8.4. So I have to go up to 8 centimeters, 0.4. So going to 23.1, I need to go up 8. So it's 1, 2, 3, 4, 5, 6, 7, 8.4. So my third point is there. Now it looks like these points are lying on a straight line, so our experiment is very effective in determining the relationship between mass and volume, because if I put my ruler down to cut through the middle of all of these crosses, my points, it also goes through the origin of the axis, which is the 0, 0 point. So oops, my hand drew a non-straight line. So I can see that all these points are lying on a straight line. So this is a straight line graph. In maths we would say it is a linear graph. And this linear graph tells you something about the relationship between mass and volume. If I would double up on the volume, the mass would double up. So we can say that mass of a substance like the wood is directly proportional to the volume of the object or substance. I want to make use of this opportunity to also bring the slope of the graph into meaning. So the slope of the graph is how steep the graph is. It is also called the gradient of the graph. Now, to calculate gradient, you would say rise over run, which is the change in the y-axis over the change in the x-axis. So if I go to the last point or the second point of the graph, the change in the y would be from 0 to 23.2. So the change in y would be 23.2 minus 0, and I'm using 0 because this line goes through the origin. That would be the rise. You went 23.2. Oh my, I'm making a mess here. It's the change in y over the change in x. So this part, the change in x is 23.2 minus 0. That's the change in x. And the change in y would be from 0 to 8.4 is what we used. So it's 8.4 minus 0. So the rise over run, which means gradient, would be 8.4 divided by 23.2, which is 0.36. We'll round it to 2 decimals. 0.36. Now, what is the meaning of 0.36? If I have to calculate the density of the wood, I would need to take the take the mass and divide it by the volume. So in this case, it's the 2.9 divided by 8, which is what? So 2.9 divided by 8 would give me 0.36 if I round those values. The second piece of wood, to get the density, it's the mass 4.12 over 11.3, and if we calculate 4.12 divided by 11.3, I get 0.36. Fine, we're pushing it a bit here, because if I have to round 4 to 5, I could go from 0.37 to 0.37, but obviously the calculations here were most probably a little bit rounded, the measurements. And the last one's density is 8.36, I'll use the measured values, divided by 23.2, and 8.36 divided by 23.2 is equal to 0.36. So the gradient of the graph has meaning. The gradient or the slope will give us the density of the substance. So the gradient is 0.36 grams per cubic centimeters. Right, that is beautiful. Sorry for the mess I made here and there, but in science there is always meaning to a graph. We can interpret the graph by saying mass is directly proportional to volume from the straight line that goes through the points that we have plotted, and it goes through the 0 point, and the slope of the graph would give us the density of the substance. Thank you for watching. I hope this video helps you.